after this masterclass in this hackathon, has the potential to impact the millions of lives under the ABDM ecosystem, that is Ayushman Bharat digital health ecosystem. It has the code you write here has the immense potential to impact millions of lives. So, and we are incredibly proud to supported by the elite group of our partners, that is our academic partner IIT Hyderabad and General Insurance Council, GAC, Nat Health, and IAA, that is India Insurance Tech Association, and standards and quality leaders like NRCS and NABH, and our technology partners Google. To fuel this your innovation, I'm happy to reiterate that we have a total prize pool of 50 lakhs across our problem statements. We want this hackathon to be a catalyst for you to push the boundaries of what's possible with the NHCX technical framework. Today's masterclass will be your deep dive, where our team will take the masterclass and will answer your doubts. And I encourage you to be inquisitive, challenge the existing bottlenecks, and collaborate with us. Because we are not just building a platform, we are building a DPG, that is digital public good for the health ecosystem. Let's use this time to innovate and refine your strategies and create something truly valuable for India's healthcare ecosystem. Thank you, and we can go ahead.
Thank you, sir. With that, without any further ado, let's start the session for today. Yagnesh, sir, I'm just sharing my screen. Over to you for the primer on NHCX.
Yeah, thank you, Sadhana. Yep, go to the very good morning, everyone. Thank you for joining NHCX Hackathon Masterclass Session 2 today. Hope all the participants are new, joined first time. Even if there are any repeated participants, so I would like to make the same pitch what I did in the last session, just to make you understand what we are trying to achieve through this National Health Claims Exchange Hackathon. Not only hackathon, but as a overall, what is that we are trying to achieve as part of this mission objective. So again, just to start with, imagine I am going to take one real-time scenario. What happens typically in hospitals, right? There are 3 different patients admitted in the hospital, right? All of them have the same diagnosis, and it's the same procedure performed. So when it comes to the health insurance approvals, right? Though it is the same doctor, same billing team, they have to operate in 3 different portals, right? Because patient 1 may be covered under insurance company A, patient 2 may be covered under insurance company B, and of course the other patient may be covered under a government scheme. So each payer have their own protocols, right? And of course they are governed by their own systems. So now what happens generally, right? The hospital billing team typically logging into these 3 different portals. They follow 3 different submission workflows. It may be same, but in general, right? So they may follow 3 different workflows based on the ailments that you actually submit. And of course, there are different types of documents as per the insurance company guidelines, or I mean, of course, TPA guidelines if required. And they used to map this data into 3 different formats. It is not same, right? So they may have their own the document structure. So they have to map. The hospital staff, the billing staff has to map all these documents into 3 different formats. And then finally, to track, they have to open again all these portals and then check whether the claim or pre-authorization is approved or not, any query. So it is a very tedious job for them to track and then update the actual IPD team, and then take further course of treatment, right? So even though the clinical case is very identical, the claim journey becomes completely different. This is called fragmentation that we see typically today in India across all the insurance platforms. So it actually increases the administrative cost. It in turn increases the operational cost. Of course, as and when you make a man to do the work, obviously it increases the operational cost, right? And it also delays the processing and query life cycle. So when I say the processing and query life cycle, typically when there is a query, even today most of the insurance companies are TPS, they send email communications. Even hospitals, right? Sometimes their system may be down, or okay, some problem may be there, so they used to send a communication through email, and sometimes they upload in the system. So it is completely different from insurance company to insurance company, and it delays the whole processing life cycle. It increases the ultimate settlement turnover time, which actually not as per the guidelines of IRDI, or okay, in case of the insurance companies, it's always a problem for them to process in time, because of various the documents verification, the post-op verification, everything has to be happen manually with different systems. Now, ask yourself, can this model scale nationally? So I don't think it is next to impossible to scale nationally when you have these kind of systems, right? So that is why the vision of one rail many claims emerged. Instead of hospitals navigating multiple disconnected systems, we envision a single standard digital rail. So it means hospitals, through their own HMI software, they submit a claim. It goes to the National Health Claims Exchange. From there, it actually goes to the respective payer systems, and vice versa. So when you integrate a common interface to do the claim lifecycle events, right, from one single interface, so it is nothing but a standard platform, right? It is nothing but a standard interface where it actually covers all required information that is to be submitted for a given claim, right? So this is what we envision as part of this whole NHCX. Can just go to the next slide. So when I mean, of course, as I told, the NHCX acts as a structured claims exchange gateway between provider systems and payer systems. So what we are trying to do here, we are not replacing any provider systems or payer systems. Obviously, the providers' hospital management systems will be there as is, and payers, their claim adjudication systems will be there as is. We are not making any change in their own IT systems, but we are actually standardizing the whole communication protocol. So when I say communication protocol, we insist hospitals to create a claim document in a structured format that we will actually talk a little later. So when you do this structured communication, right, from a provider to payer app, so what that NHCX does here, so we simply take the request. I mean, what NHCX does, NHCX actually take the request from the provider systems. It actually validates whether this claim has come from a registered participant. When I say registered participant, each and every participant in this whole ecosystem, like hospitals, insurance companies, TPAs, regulatory bodies like IRDA, NHA. So everyone must have a unique participation code, right? Participation ID, and each and every participant will have a role in it. So when I say the NHCX validates the participant depends on the role, it actually checks and goes into the respective registries. If you see in the bottom, right, there are digital contracts, ABHA, HFR, HPR, and payers. So these are all the registries that we maintain at national level, where any participant who actually interact through this NHCX, we validate against the respective registry and then say he is a valid user or valid participant. So you can consider this as a legitimate claim. It's vice versa, same way, right? So it doesn't replace any hospital systems. It doesn't replace any insurance systems. It actually standardizes the whole communication protocol. So if you see the key stakeholders, as we see in the left side, right? So there are beneficiaries, there are insurance companies, there are TPAs, healthcare providers like hospitals, clinics, and of course regulatory bodies. Each entity have a participant code, as I explained. So all these entities access APIs that are actually enabled through NHCX to submit a claim or submit a specific whatever structured information that is related to that particular use case. And all these APIs are accessible through a secured ABDM based authentication protocol. So we must be aware, right? I mean, you all must be having ABDM sandbox access. If you're not, okay, anyway, to play with NHCX, you may need to register ABDM sandbox process to get the credentials. So once you have it, right, so you will get client ID and secret key, and it actually have a specific role in it, right? So when you access a particular API, system checks whether this particular participant has required authorization or not. Until unless you have it, okay, you can't even play with it. You can't even send the communication to through the NHCX. So this architecture ensures a secure identity verification. It is of course role-based access, and of course it standardizes whole life cycle of the claim. And we actually maintain, as part of NHCX, we maintain complete audit traceability. So tomorrow, when a claim actually submitted by hospital, but it is not reached to peer system, so we should have a mechanism, right? So because there could be some issues with respect to SLAs, so anyone can claim saying, okay, this is not received by me. So we should have a mechanism to trace out what exactly and what time, okay, the claim is submitted by hospital and what time it is reached to the payer. So everything is actually recorded in the system, though we are not reading the claim information because it is more sensitive. We do not want to read the claim documents, okay, by anyone other than, okay, recipient, the intended recipient. When I say intended recipient, when you make a query, when you make a claim to particular participant, means particular payer, only the payer system can read the claim information. It is encrypted by using a public key of the recipient, so that they can decrypt by using their private key, and then they can actually adjudicate, they can pull the data, they can deserialize the data and then put it into their systems and then process it. So we ensured during the design process, okay, we ensured the data that you are submitting, means the hospital is submitting, cannot be read by anyone, not even IRDA, not even NHA. Why? Because see, IRDA doesn't need the claim information until unless there is a complaint from a beneficiary or, okay, any third party provider. Even NHA doesn't want any personal information or any claim information, because we don't care. We actually need only the statistics to understand, okay, the claims that are processed through NHCX, right? So we actually ensure, okay, at most privacy in terms of the data that you are actually dealing with. So there should not be any issue or there should not be any privacy concerns by the patient or, okay, by the hospitals when you are exchanging information through NHCX. Yeah, go to the next slide. So when we are sending, right, so if you take one typical life cycle of the claim, I will give you an example, okay? So I will explain through an example so that it is easy for you to understand what exactly that we are trying to standardize. You are a patient, right? You have a policy, and you purchased a policy from one of the insurance company. And of course, when you purchase a policy, they will give you a digital copy. It's a PDF document, right? Or a physical copy. It's a printed document. So it may be sent to your email ID, or you might have kept the physical copies somewhere in your alarm, somewhere wherever you want to keep it, you might have kept it. And one of the patient in your family admitted in a hospital, right? But suddenly you forgot, or you have misplaced those documents. You don't have any physical document, or you don't have any document which can actually say you have a policy or not. So what we are trying to do as part of this whole exercise through NHCX, right? We instructed through IRDI that all insurance companies, when they are selling their policies, they have to tap the policy with ABHA. When they tap that policy with ABHA, it means hospital or you yourself can discover your policy using your own mobile ID, mobile number. You don't need a physical copy, or you don't need to remember, where exactly my digital copy is there. Through that mobile number, you can discover your policy. Not only you, hospital also can discover your policy, and they can actually see the policies that are tapped to your ABHA. So when I know a particular policy code or policy number, I can actually discover the whole the policy information. So how do I get that? So there is an API that we have enabled, which is actually very important critical API, insurance plan request, which actually takes a provider ID and the policy code, and of course, if possible, beneficiary ID. Beneficiary ID is not mandatory to get the policy description, policy details, but the policy code, which is actually coming from the discovery policy API, by passing that policy code along with the provider ID. So provider ID is nothing but the hospital code that you have used to register in NHCX. That is a participant ID. Using this tool, you can call an API on NHCX to get the entire policy description in a digital format. When I say digital format, it actually covers every aspect, every element of the policy. What are the elements that are covered within the policy? What are the limits for each and every element? If there are any mandatory documents, if there are any limitations, if there are any exclusions, everything will be provided through this insurance plan. It means when you get that information onto your IT system, right, in the provider system, since we are talking about a standard interface for claim submission, right, they will actually check the elements that are required, means the procedures that are required before they actually send for pre-authorization or a claim. It is like a pre-admissible check, right? So when I know this whole information in advance, I can very much actually do all kinds of validations before it actually goes to the payer system. And of course, there are other checks, payer side checks that can be done through a different API. But with this data, the provider software can actually do all kinds of admissible checks. So this is where, we are trying to build an engine as part of this hackathon. As I understand, you are actually going to generate a standard insurance plan object from PDF documents that are available in the market, or of course we can seek guidance from insurance companies. And then this is the first critical aspect. So most of the insurance policies today, all of them provide only the very basic guidelines. Everything goes to their system, and then they do the validation in their IT systems or with their policies, and then they respond saying, okay, this is eligible, this is not eligible. We do not want to have any such query or any such denials after we implement this NHCX. The second important API that we actually provided is that coverage eligibility. This is also very, very important API. As I told, right, I have got the policy information using policy code and then provider ID. So when I say provider ID, it actually gives you the policy that is required only for that hospital. Let us say there is an ophthalmology hospital. When I generate my policy description, I don't need to share the ailments that are covered by through cardiology or cardiothoracic or nephrology. It is not really required for ophthalmology hospital, right? So these are all specific to that particular hospital for the particular beneficiary. So when I want to check the patient eligibility, so now there is an API called coverage eligible request. So there are again different purposes that we have. One is validation, discovery, validation, benefits, and then authorization. So each and every purpose has different rules, right? So if I just want to check whether my policy is enforced or not, I simply send a validation purpose. If I want to know the benefits that are covered or not, I will simply use benefits as a purpose. If I want to know what are the auth requirements, when I say auth requirements, before you submit a claim or pre-authorization, you want to know the mandatory requirements. Mandatory requirements matlab the documents that are required for a given ailment, because you do the diagnosis, right? When you do the diagnosis, you might have seen some documents. Then only you will say this particular patient requires a treatment or it requires a surgery, right? So on what basis you are actually saying, okay, this particular treatment is required for this particular patient? So those kind of basic requirements can be retrieved by using this coverage eligibility response, right? So there is another API, pre-authorization. The pre-authorization is also, of course, so once I know the checks, right? Once I know the other requirements in advance through coverage eligibility response, now I am ready to submit a pre-authorization. So what extra that you are going to give as part of pre-authorization? So now you have all the documents that are required and you upload them, and then you choose the required the treatment, and you actually give. There are 4 blocks that we actually expect as part of pre-authorization submission. One is diagnosis, treatment plan, support information, and then treating doctors, means doctors team, right? So these 4 blocks are must, along with the basic demographic information such as patient name, patient ID, all those things. So with this information, I simply click pre-authorization. So when I click pre-authorization, it again goes to the payer, and payer do the adjudication. So most of the time, since here is again another important aspect that we want to achieve as part of this NHCX system, right? So now, as I spoke earlier, the entire the claim journey is manual and unstructured manner, right? It is always a document. It is always a scanned document. So now, when you are submitting through NHCX, each and every diagnosis or treatment plan, or even the support information like the investigations, everything can be coded as a standard information, standard structured document. ABDM has all different HI types, right? And then you can actually submit all of them in a structured format. So when I say structured format, this information can be read by a machine automatically, and then you actually enables an auto adjudication without any human intervention, right? So the pre-authorization can be done within no time. So today, to get pre-authorization, you may need to wait for 3 hours max. 3 hours, okay, it depends on the policy, depends on the type of ailment that you ask for. So it goes 3 to 6 hours, right? But it should be instantiated. It cannot be, I don't even, when I have a document which is structured document, can be read by a machine, I don't need to wait. I only check the diagnosis. I see the documents that are submitted, support information. I also see the processes that are required. When everything is standardized, I will have a rule-based engine somewhere, some kind of AI engine or whatever it is. It does the validation, and then it says, yes, this can be approved, or this can be denied, or this can be queried. So immediately the response goes back to the hospital. Same way we have claim submission. So after treatment, okay, you are going to submit a claim with all billable items, where again you do the similar kind of structured information only. There is no other mechanism. And we do have certain scenarios in insurance journey where during adjudication, if payer requires any additional documents or additional information, so you have an API called communication API. Okay, it actually send a communication to hospital. There are multiple scenarios, not just only the adjudication purpose. If they want to communicate saying there is a change in the policy, for example, right? And there is a change in the rate for a given policy. How do I communicate to the provider softwares? Because I have taken an insurance policy which actually have all the details along with the limits and all, right? But I change the limit, or I change the I removed one of the packets from the policy. So I should be able to communicate through some mechanism, right? So that is where, okay, the communication request useful. Similarly, we have reprocess API. So this is another use case that we typically see in the insurance industry. Like there could be a partial approvals, there could be rejections, right? So as part of the payer guidelines or IRDI, hospital has a right to appeal, okay, and obviously this is very much required during claim adjudication process, because claims once it is submitted, when patient left the hospital, right, there is no other go, so hospital has to clarify the things, but sometimes the payers, means insurance companies, reject it. So now there is a provision made to the hospitals to appeal for such scenario. So that is the reason, okay, there is a reprocess request API provided. And of course, payment notice is an intimation that payment is made. It will have all the information like the payment made, what is the TDS deduction that is done by the policy, by the payer, in case of any adjustments. So how much amount that I adjusted, in case of any recovery, how much amount that I recovered, penalties, everything will be part of that payment reconciliation object. So these are all the APIs that we have enabled through NHCX, and the providers and payers use the respective APIs wherever applicable to communicate through the NHCX. Yeah, can you go to the next slide? Yeah. So we spoke about so many things, right? So as I told, there is an insurance industry, there is a healthcare providers, there are citizens. If citizens, I explained, okay, what are the various benefits that citizen can actually get. The same way, there are benefits for health providers also. As very simple thing is, they can actually reduce the operational cost, because it is single interface. They can use that to submit claims to multiple insurance companies, right? Similarly, okay, the eligibility check can be done during admission itself. So when I say during admission, in their IPD or okay, OPD registration form, if I am a cashless patient, I select my payer information, right? So again, as I explained, I give my Aadhaar ID, or I give my mobile number, I get all the payers that are listed. So if I'm tagged with one particular insurance policy, that insurance name will come automatically, appear automatically, and then I enter my Aadhaar number, and then I actually check the whole eligibility before I invent a later stage. So they can actually have see, once I have all these systems in place, right, and it is easy for me to communicate saying, okay, I'm ABDM complaint hospital. When I say ABDM complaint hospital, I can be eligible, or I should be eligible for treating any insurance patient. So the network hospital guidelines can be uniform again. So this is again a policy decision, but yes, so eventually we want to make the guidelines as much as uniform, so that okay, when I'm serving a patient under PMJ or under HDFC Ergo, I should be able to treat patient under any of the insurance policy, right? So there should not be any barriers or any limitations. And of course, they get the immediate approvals without any delay. As I told, okay, if you put systems in place, the approvals will come immediately without any manual intervention, without any delay. Same way insurance companies also. So the same thing, they can do the auto adjudication, they can perform all kinds of checks without any manual intervention. They only can send the complex claims, okay, where it requires special verification by super specialty doctors. Otherwise, all whatever the providers has, okay, the same same advantages will be there for insurance companies also. But another interesting point that we want to achieve, okay, as part of this whole NHCX, for insurance companies to avoid the fraudulent claims. So if you see the protocol, we will discuss protocols whenever you actually try to see the thing. So when you see the protocol, right, we actually mandate the protocol should pass through Aadhaar. I mean, protocol should have Aadhaar number as a mandatory field. So when I say Aadhaar, your NHCX actually understand, okay, this whole claim is submitted by the provider A, for a given patient, beneficiary B, right? So it will have an intelligent system. I mean, we have a system where actually it actually sends an alarm when I see a similar claim is submitted to a different payer. So we will actually communicate to the insurance company A and insurance company B. We are not saying it is a fraudulent claim, but we will actually intimate saying, okay, there is a claim submitted by the hospital for a given patient, okay, in two different cycles, which actually is suspicious. So this is one typical challenge that we see that we are trying to avoid, we are trying to eliminate when we start using this NHCX thing, right? So these are the benefits that are envisioned as part of NHCX. And mostly when you try to see the documentation that is available in the NHCX portal, abdm nhcx.abdm.go.in, so where you have a document section, you please go through all the documents that are required. Mostly you may need to understand the FHIR. That is a critical part of the whole system. Otherwise, the technical protocols, the preparing a standard bundle as part of RFC 7516 pattern, or okay, preparing a protocol header with required attributes. Okay, they are very detailedly given, and you just go through. And if you have any doubts, any clarifications that are required, you can very much post, and we will be ready to answer. We will be providing all the details. Yep.
Thank you so much, Yagnesh sir. On that note, I think Yagnesh sir has set up nicely for the primer on FHIR. I invite Google and NRCS to take over.
Hey, thanks, Arna, and thanks, Ignish. So I'll be talking briefly about what is FHIR. This should help you. You should be able to build. You should be able to build applications using FHIR after this, hopefully. Okay. So let's break down what HL7 FHIR actually stands for, right? So if you see, as the acronym tells, right, F stands for fast, which means the standard is fast to adapt and model. So if you take any typical web developer, right, he can just look into the file documentation, and they can start build the applications starting from day one itself. And healthcare, right? So this standard, right, is specifically built for healthcare domain, so that all the complexities involved in healthcare domain, like clinical observations, billing, insurance, etc., right, can be easily modeled using FHIR. Now, interoperability. So this is the ultimate goal, right? Wherein it makes sure that different systems, right, different healthcare systems, when they exchange information, they should be able to understand each other. So that's the main ultimate goal of FHIR. Now, resources, right? So FHIR breaks down the data models into smaller building blocks called resources. For example, patient resource, observation resource, etc. Right. So if you want to build model anything, right, you can just take these building blocks and then you can just snap them together so that you can model any clinical event using FHIR. Now, why did we need FHIR, right? Historically, they were like systems which are already available, like HL7 version V2 and CDI documents, etc. Right. While they were rigid, right, and then groundbreaking during their time, it was notoriously difficult to build modern applications, especially because the specifications were very massive. So FHIR was specifically designed to overcome these limitations. So FHIR is actually the next generation standard, I could say, to build our modern data exchange needs, especially. Yeah. Next slide, please. So talking more about the interoperability, I'll just take an example. Let's say a patient, right? He wants to visit multiple hospitals, let's say. So first he goes to the first hospital, and then he gets the treatment done. Now when he moves to the second hospital, so let's say if the information is not shared digitally with the second hospital, the patient might have to carry all the medical documents, physical medical documents, and have to explain to the visiting doctor the entire details, right? So what if, let's say, the data was exchanged to the second hospital digitally, then the clinicians will be more, can make the treatment more faster, right? And not only the clinicians, even the insurance providers, etc., right? They can take the claims faster. I mean, that's the whole point in why like how FHIR makes the interoperability more easier. Yeah. Next slide, please. Yeah, talking more about FHIR, right? So the core heart of it is the RESTful FHIR, RESTful API, right? Um, so different systems basically interact with each other using these lightweight modern formats called JSON or the XMLs. It also contains a list of open source tool, which is easily available at free of cost. People can start building these applications easily and also very fast. And not only that, FHIR contains a massive community of implementers. Like there are like thousands of developers, clinicians, IT healthcare professionals who are constantly collaborating on this. Uh, Next slide, please. So one of the smartest designs, I would say, like FHIR handles how the FHIR handles the complex data is that like it follows the 80-20 rule. The core FHIR specification focuses strictly on defining what is the 80, like focus on this 80%, like which is mostly required for all the systems worldwide. Now, what about the other 20%, right? So if you see in healthcare, it is very unique, and also like there might be a lot of local regulations, right? So FHIR basically handles to handle this FHIR. What it does, it allows you to extend the base FHIR specification and handle these local requirements more very easily. So if you take an example, right? Yeah, can you come to the previous slide? Yeah, this one. So if you take an example, right? FHIR defines what the base specification needs, which most of them need. Now, let's say if you're building one specific applications for a particular, let's say, public health use case, right, and which needs nationality to be included. Right? So you can easily extend the base FHIR specification to include this nationality. So in that way, you can include whatever you need without breaking the core specification, right? Yeah, that's how it handles extensions. Yeah, next slide. Yeah. Now, where does all this FHIR live, right? You can find the full FHIR specification on this hl7.org/FHIR, right? So it is completely open source, and then it is there entirely on the web. If you see this, this is like a build like a modern web portal, like where you can find like a lot of hyperlinks. You can easily click on those hyperlinks and then search for more details. Yeah, next slide, please. Okay. So coming to the data model, right? So you can find that you can find like more than 200 FHIR resources, and this list keeps on growing day by day. Right? So instead of sending one big document, right, you can actually pick what you need for your use case and model your clinical event based on that. So let's take one common scenario, right? Let's say a patient visiting a hospital, right? So you can start with a patient resource, which where you can dump all the demographics information there. Then for the patient to capture the visit information, you can create an encounter resource, which can include details like who the treating doctor was, like when it happened and where it happened, right? And finally, let's say when doctor takes some readings or that he does a treatment, right? These readings can go into, let's say, observation resource. So combining all these resources, right, you can easily model one clinical event. Yeah. Yeah. Next slide. So let's break down what's there in one of these FHIR building blocks, right? So you can see in any FHIR resource, right, you can see these exact four sections. The first is metadata, which basically is the ship. You can consider this as a shipping label on a package, right? It doesn't contain the actual medical information, but it contains all the tracking identifiers for tracking the details. Now the narrative. So narrative is like a plain text, human readable data, right? So for example, if why this is needed. So if at all a receiving system, right, fails to decode the message FHIR resource, right, then what the doctor can do is that he can just look into this plain text, and then he can understand what this data can contain. Thirdly, extensions, right? This we already discussed. This basically is there to handle unique custom data for particular localized guide based on localized guidelines. Now we have the actual content, which is a core payload, which is the body. So this is the actual structured machine readable data. So it contains details like, for example, gender, date of birth, and test results. All this go over here. Next slide, please. Yeah. So this is a patient resource. This is a snapshot taken from the FHIR website. Right? If you see, like, there are details which can go under the patient, like identifier, name, etc. Right? So this is the 80% specification which most of the health systems need. Now, if you see, like, across next to each fields, there are like numbers like 0 hashtag, right? So this says like this tells exactly the receiving system that how many items you can expect. For example, for a page, for a phone number, right, you can see like the resource can contain 0 or more phone numbers, right? Next slide, please. Yeah, this is an example of one instance of a patient resource. Um, so you can see all the details here that can go into a patient resource. Yeah, next slide, please. So let's talk about how when the data is exchanged between multiple healthcare systems, how they understand each other. So terminologies are the core backbone of what is called semantic interoperability. So it's not about just moving the data from system A to system B. It's also about ensuring that system B completely understands what the system A has sent. So to achieve this, right, we rely on what we call as coded concepts. So instead of systems sending free text data, which the receiving systems may or may not interpret easily, we map all these clinical values into specific machine readable codes. For example, we use a LOINC for representing lab tests. Similarly, SNOMED for clinical findings, right? And of course, to accommodate local guidelines, we can also define custom code sets. Custom code sets is also possible. So if you see in the diagram, this is an example of a LOINC representation for a lab test called HbA1c. And also you can see like how it is represented in the FHIR resource. Can you go to the next slide, please? Yeah, value sets, right? So this is where this is what will help FHIR, right, in representing things structurally, right? You can think value sets are like a controlled list of values, right? So instead of allowing like multiple possible values, we FHIR specification helps to restrict fields for a particular column to a set of values alone. For example, in the slide, if you see in the picture, for representing gender values, right, the FHIR specification strictly says this is only the 4 possible values you can choose. So it's highly reliable. Yeah. Yeah. Next slide, please. So now we know like what FHIR data looks like, right? And how do we move the data from systems like system A to B, right? And the answer is RESTful APIs. RESTful APIs are already a proven web technologies, right, in today's modern world data, and FHIR relies completely on that. So earlier, I think The earlier specifications used to rely on messaging systems, but now FHIR uses like these web commands like read, post, put, etc. to basically exchange information between systems. So see, this is very simple, and then any modern developer can start building applications using this. Yeah. Next slide. So now let's say you have FHIR data in the system, right? Now, if you want to quickly find out exactly what resides in the database, you don't have to take the entire dump. You can just you leverage something called search APIs, right? And what is a search API? Like it's also a specification which FHIR gives. Where does it present? Like if you go to a FHIR website, right, and open any patient FHIR resource like a patient, you can go to the bottom of the page where you will be able to find a table of search parameters, like how it is given in the image slide here. So, for example, if you take an example, right, if you want to search a list of patients whose birth date is 2020, right, this is a URL format which you can give to the FHIR server, and then automatically you'll get a list of patients. Yeah, talking about a FHIR server, right? A FHIR server is nothing but a system who has basically implemented the entire specification. Right? So and file system helps in making sure you can exchange informations in file format. Yeah. Yeah. Next slide, please. Yeah. So now let's look at one example, right? How FHIR can transform the day-to-day data into like how can it represent the day-to-day data. So we can take an example of a typical lab test, right? On the left hand side, you can see it's a lab test, and on the right hand side, you can see like how FHIR has broken down in representing in using FHIR resources. Right? So first, you see the overall report itself, right? When it was run, when it was taken, and then who basically did the lab tests, right? This can be represented in a diagnostic report in FHIR. So diagnostic reports is like the parent resource which can hold references to all the child references, right? For example, the patient information will go into patient resource, and from the diagnostic report there will be reference to the patient resource. Similarly, the treating doctor information can go to practitioner, right? Now coming to this actual lab test, right? The entire table, like each record in the table will be represented as one single observation. So if you see how neatly we are able to now map the lab test using FHIR resources, right? So now this particular digital data is very easily understandable by machines, and then you can, if you want to just share this lab report, you can just bundle all these FHIR resources into one bundle, and then share the bundle with the receiving systems. Yeah, that's about FHIR. I think Sally from NRCSS will talk more about how ABDM has adopted it and NHCS adopted it. Yeah, thank you.
Yeah. Hello. Hello. So, instead of Salim, I will be taking up the part for adoption of FHIR in Indian walkthrough of FHIR artifacts in ABDM and NHCX. Giving a brief intro about myself, I am Chinmay Buttar, working at the NRCS team, which is the National Resource Center for EHR Standards in India, established by the Ministry of Health and Family Welfare to help implementers adopt various healthcare standards in their systems. So, next slide, please. Yeah. So, first of all, let's try to understand the various eh, India's FHIR artifacts that are introduced as a part of two flagship programs that are introduced. One is the ABDM, which is Ayushman Bharat Digital Mission, and NH6, which is National Health Claim Exchange Programs. So, considering the various use cases of ABDM and NHCX, the base specification, as Mr. Chandrasekhar sir has informed in for the FHIR, had to be modeled to fit for the various workflows and the use cases that are defined. So let us go through some of the use cases that is introduced for that are required for the ABDM and NHCX. In case of ABDM, the first and foremost important use case is to cover all the records supporting the continuum of care across the ecosystem. So, as for an example, by using the case of a particular patient, when he goes from one particular hospital to another partner in the health ecosystem, by by implementing this use case, he should be able to carry all his related health information, and it is easily accessible to the various healthcare partners in the ecosystem without the burden of him carrying it in physical formats. Plus, there should be a minimal to fully structured data exchange and easy onboarding of non-standard and structured data systems. For the case of NHCX, Yagnesh sir has so explained, the most important workflows such as uh, claim processing, pre-authorization, coverage eligibility checks, getting data for the insurance bundles requires exchange of documents and all the other supporting info between the payers and providers. And also, this particular exchange can be a bit operational in cost, and it is time consuming for claims processing. So by introducing NH6, we are trying to reduce this operational cost related to the claims processing, and at the same time, we want to enable transparent and efficient claims processing. So, as a part of FHIR, the FHIR as a base specification provides us various resources. Mm, yeah. So, so as I was saying, so FHIR
Yeah,
as a base
sorry,
yeah,
my
yeah.
internet got cut.
Okay,
Sorry.
no problem. Yeah, so continuing, so FHIR as a base specification provides us with a collection of resources, and resource in this sense can be defined as a unit of exchange which is justifiable in interoperability. So, considering the 80 to 20 use cases, 80 to 20 rule that was explained by Chandrasekhar sir, all of these use cases are additional constraints that must be applied over the base 80% specification. So, as a result, after applying all of these constraints for ABDM use cases and NH6 use cases, as an output of this process, the FHIR resources are converted to something known as FHIR artifacts or profiles. And this particular collection of profiles is available or provided to the implementers in form of a resource which is known as FHIR implementation guide. Can you please go to the next slide? Yeah. So the FHIR implementation guide with the current build version of 6.5.0 is based on the base FHIR specification R4 4.0.1. Now here on the left side, you can see we have given you various stats containing displaying how many FHIR profiles we have so far created, out of which there are 7 clinical artifacts which are responsible or which are used as a structured data format for exchange in the ABDM ecosystem. Then we have 6 health claim exchange profiles which are used for the structured data format in the NHCX ecosystem based on the various different workflows. So FHIR being used as a standard to represent this structured data also allows the usage of various other healthcare standards such as SNOMED City, LOINC for representing terminologies SNOMED and LOINC as terminology systems to represent healthcare concepts and medical data in coded format. And SNOMED City and LOINC are already a part of EHR standards that were defined for the India case. So, by using this SNOMED City and LOINC, we try to we improve the semantic operability interoperability between the exchange of structured data between various partners in the ecosystem. Next slide, please. Yeah. So let me give you a brief view of how exactly the data structure, how the record structure for a record artifact of ABDM is in general way. So in any given 7 artifacts that are displayed here, which are diagnostic report record, discharge summary, prescription record, OP consultation, immunization, wellness, and health document record, each of them can be divided into two parts. First is the metadata. The metadata tells you about who exactly and what it is about the structured clinical data being represented. So in case of metadata, what we represent is who the structured clinical data is about, which is represented by the subject, who is the author, who is actually, doing the test and giving out the results, which for the structured clinical data, what was the encounter between the subject and author, who is the care provider. In this case, it could be an organization, clinics, etc. Now, this particular metadata is common across all the given 7 health artifacts. And then we come on to the structured clinical data. So the structured clinical data, if you look at the images that have been provided for each health artifact, it is divided into multiple sections, and each section itself contains a separate FHIR profile which is used to capture this clinical data. So like for example, if we take the diagnostic report record, here apart from metadata you see 3 different sections which says which tells that this particular health record is capturing the diagnostic data either via laboratory case or for a imaging case, their details, their results, interpretations, along with a document reference where you can attach your actual PDFs in a binary format in the structured data format. So in this way, each health artifact in ABDM captures the structured clinical data and metadata for whom uh, of whom the structured clinical data is being captured. Next slide, please. Yeah. So as Yagnesh sir has discussed, these are some of the key use cases that are covered as a part of NHCX. We have coverage eligibility to get the coverage details as to what is covered and what is not. Pre-authorization for actually checking whether the given particular procedure that we are trying to perform and the cost is certified or not. Then the claim, which would be the actual claim processing, payment for the notification that actual payment is done by the payer to the provider. Communication is for inter communication regarding as a what we could say supplementary part of all of the above main processes for coverage eligibility, claim, and pre-authorization, and reprocess for reprocessing the claim again if required. Can you please move on to the next slide? So again, this is a FHIR profiles for NHCX. As you can see here, the NHCX FHIR profiles, or the in this case the bundles, have been defined as per the NHCX use case, which are defined in the NHCX specification. So for the various APIs that have been defined, we have created the FHIR bundle as a payload to support the exchange for the API. And there are various use cases such as I have said, predetermination, pre-authorization, claim. You can use claim bundle, and as a response, when a provider submits a claim bundle, the payer replies back with by populating a claim response bundle. Same for the coverage eligibility request, and as a response, coverage eligibility response. For other supporting workflows such as communication, we want to search search a particular information about a claim, either to reprocess it. We use task bundle, and to get all the related details for the insurance plan, you can use an insurance plan bundle. So FHIR profiles for NHCX are basically kind of collection of various FHIR profiles representing the workflow in payload that is to be supported for the given use case. Next slide, please. Right. So as I said that as we modify the base file specification resource, we have to implement the constraints that have been identified for both ABDM and NHCX use cases, and this generates into something known as a FHIR profile. Now, while reading a FHIR profile, you will encounter some new terminologies, and these are such as cardinality rules. The cardinality rules tells about the file profile, what are the mandatory elements, what are the must support elements, the terminology binding at a given element that tells what particular terminology system is being used to represent the data at that particular element. There is text summary that provides a human readable summary of the changes that have been made. There are views on how to view a profile. There are differential views, a snapshot view, and so on. So as you read a particular file profile for the ABDM, you come to understand how exactly the use case is modeled in that given data structure and how it should be populated as a part of a payload to be exchanged. Next slide, please. So let's go through one of a simpler way of actually understanding how ABDM HI type is populated. So as you can see in the image, you can see we have given a sample data for a hospital for an OP consultation note. Here there is patient name, doctor name, medical license number, which is above the green line, and that can be considered as a metadata for the given OP consultation note representation. Down, you can see what is the actual clinical data that is being captured, which is the chief complaints. There is foot swelling, diabetes mellitus type 1. What are the physical examinations that were done? What are the allergies that are being observed? His medical history, family history, current medications, and so on. So these are all the separate sections of a OP consultation note document that is generally populated as a part of uh, a visit by the patient to the given organization. Can we go to the next slide? And now we will be coming to how it is being modeled in a FHIR health artifact. So for the ABDM health artifact, it is important to consider that the resource that we are using to populate all of this is known as a bundle. Now, a resource of bundle in FHIR can be of different types. For ABDM use cases, the type should be of document as is mentioned in the image itself. So the resource type will be a bundle and the type of the bundle will be always document. Now FHIR specifies the rule that for the type document, the first entry is a composition. So to consider analogy, here in this case of OP consult note, the composition will represent what exactly the OP consult note is all about, the context about it, what it exactly contains. So in composition, you will be marking all the sections that what exactly was covered in the OP consultation note, as well as the metadata, who the subject is, who the author is, what the encounter is all about. And for each of the sections mentioned in the composition, there will be a separate entry actually showing the data for that particular entry. As you can see here in the blue box, we are actually indicating the condition which is known as foot swelling. And if you see in the highlighted red box, we are trying to represent this foot swelling condition using a terminology of SNOMED city code. Now, by using these terminologies, we are improving the semantic operability as all the partners in the given ecosystem can have no ambiguity as to what exactly foot swelling is represented by. That will be used underlying by the same code. And the bundle itself, by giving us a structured data to follow, by providing us our standardized structured data, gives us a syntax which is modified and can be extended across the partners, thus improving interoperability and makes it easy to digest the data coming from other systems without having to worry about how exactly it is structured, since we are following the same format. Next slide, please. So let's talk about the NHCX artifacts in FHIR. So as shown here is a typical claim submission workflow. In the claim form, along with this, we do require various supporting documents, various medical supporting documents such as lab reports, what are the discharge summary, the final bill and receipts, your ID proof and insurance details. So as you see here, it is not exactly a document, but rather a collection of different related entities that must be collected together and exchanged for a payload. So in the next slide, please. So for all of the NHCX profiles, we again use the resource of type bundle for the FHIR. But here, instead of using of type document, what we use instead is a type collection. So it is representing a collection of separate required entities to make one meaningful context for the given data format. So here, if we consider the example of claim bundle, the first entry itself is a claim that represents a claim form. Here you can see what are the details provided, like patient, who is the insurer, who is the diagnosis and procedure. And in order to actually provide details for all of these entries, we have separate entries in the resource type of bundle populated. So again, it provides us syntactic operability since the structure of this so-called bundle is decided to be decided for use as a payload for the API. And for all of the internal use cases such as claim, where we are using it for either predetermination, pre-authorization, or claim, we can specify the particular workflow using the provided elements and the terminologies in the given profiles for the claim here. Next slide, please. So, as per the NHCX specification documents, we have shown over here what are the various API endpoints that are to be implemented, such as coverage eligibility checks, on checks, pre-auth, on submit, and etc. And for each of this API endpoint, along with the flow mentioned, the supported payload for this API is provided in the form of a FHIR bundle of type collection. And this is how the NHCX profiles have been modeled. Can we go to the next slide, please? So this particular references are important. The prominent ones I will go through. So the NRCS website is the one-stop shop for all the EHR standards in India. You can find various documentations, resources, presentations that we have so far added so that we can ease the implementers in adopting the standards into their systems. Along with this, for the integration of terminology support in their applications, we also provide tools, integration tools, etc. And those you can find in the tools and technologies link that we have mentioned. Coming to the implementation guide itself, the implementation guide is like the one-stop shop for FHIR understanding and integration, as you will be requiring it for the ABDM and NHCX. It contains, once you go to the link, you can see what are the various ABDM profiles, the NH6 profile, the supporting terminology, as well as example structured data with the dummy data that we have provided to give you a sense of how exactly the given structure would look like in a real life. Plus, for the last link in the implementation guide of adoption of FHIR in ABDM and NHCX, we do provide a PDF document that we have created so that implementers can go through it and actually get a hands-on, idea of how exactly the various process that one must follow for implementing the FHIR. As a important part is to actually create the structured data and to validate the structured data so that it conforms to the constraints that we have mentioned in the ABDM and NH6 file profiles. So as a part, we often encourage the implementers to go through this implementation guide, and at any point of queries further, they can reach out to us in any case, in any type of implementation support. Please, next slide. So yeah, so we will go through the problem statements walkthrough. Can you go to the next slide, please? Yeah. So let's discuss the problem statement one. So as such, the healthcare facilities are relying on the wide range of legacy clinical and administrative systems. So ABDM and NHCX are relatively new, but the legacy system contains a lot of healthcare information already. And as a part of problem statement one, what the need is to develop an open source service that could be either a microservice or a library that transforms this legacy healthcare systems data into aligned NHCX FHIR bundles for coverage eligibility, claim, pre-auth, all the other workflows, so that we can easily consume them in the HMIS platforms and healthcare application. So the expected output would be to be designing an open source and reusable component that could be embedded into any HMIS. And the important part is that the after the creation of the bundles, it should also satisfy the constraints mentioned for the NHCX profiles, so that it can be exchanged as a supportive payload for the via the APIs. In the sample data, we have provided various data dumps that can be used as an input for your input source for the so-called solution that will be implemented. And can you please go to the problem statement 3? Yeah. So this is the third problem statement. So insurance plan covers the majority details that is to be aware, like the benefits, the sublimits, the exclusions, etc. So these are predominantly provided in the form of PDFs, and as such they are very big documents that needs to be gone through, and it will be a time consuming and expensive process to convert this particular PDF documents into a insurance plan bundle structure. So what the problem statement states that we need to develop a open source service that will convert, that will ingest this insurance plan PDFs, and as an output can generate an NH6 compliant FHIR insurance plan bundles. So again, the solution must be open source, reusable, so that we can map out the extracted content from a PDFs and output an insurance plan FHIR object. Again, the main point is after the FHIR bundle or structure has been generated, it must be validated to follow the constraint set for this particular insurance plan bundle. Yeah. Now, can so I will ask Chandrasekhar sir to explain the problem statement too. Thank you.
Uh, yeah, can we go to problem? Yeah, problem statement 2. Okay. So like we know already know like most of the medical documents today, right, are there in the form of PDF documents. For example, a lab report, right, or a prescription, right. So these are all in the PDF in the form of PDF documents, right. These are let's say if you want to submit for claim processing, somebody has to review this document manually in order to process the claim, right. Um, so this problem statement is about converting this PDF document into a digital form, like which means that you need to extract all the data in the PDF document and convert to FHIR format, so that the underlying the receiving systems in this case, right, the NHCX, right, or the insurance providers, they're able to understand, like since it is machine readable, the FHIR, they're able to understand the data. Machines can understand the data, and then processing can become very fast. And so here we mostly focus on ABDM high types, right, like lab report and diagnostic reports. So we, yeah, and so what we need to do here is, like, you need to build an microservice or also a library which can basically read these PDF documents. Like, you need to find a way how to upload these documents, and then the microservice should basically extract the data, and then also find the right relevant terminology codes, like for example in this case, like line codes for lab tests, right. You might have to find the appropriate, do the line code mapping, and then create FHIR bundles, like, and then share the FHIR bundles. So when you say FHIR bundles, as we already seen in a couple of examples, right? A complete lab report can consist of multiple FHIR resources, which collectively you can form as one single FHIR bundle. That should be the output of this product. I can give a walkthrough of one sample lab report. Sanna, do you want me to share my screen?
Yeah, you can share your screen.
Okay. One second. Let me reshare. Let me know if you're able to see my screen.
Yes, we can see it.
Okay. Yeah. So this is a typical lab report, right? Which the lab providers will create. Now, when you want to extract the information from this, right? For example, you might have to extract all the patient information. So here, some of the fields are like not blank, but in a typical report, you will usually have these fields filled. So given this typical lab report, you might have to extract all the patient informations and then for example, create a patient resource and put all the demographics over there. Similarly, you might have to create an organization report to capture the details of which provider is basically has done this. And then if you see the core body, right, contains the lab test. Now each lab test can go into a individual observation resource. And when you want to represent a typical lab test, right, in the observation resource, you might also have to map to an appropriate line code also, right, so that the underlying system can easily understand like what the test is. This is basically required, right, because for example, lab tests can be represented in different formats by different lab providers, right? So maybe if you can convert this to a standard format like loing, that would be very easier for the receiving system to understand. uh, yeah, that's about lab report. Similarly, so this is a discharge summary. Discharge summary contains too many details, right? uh, so here also, you might want to extract the patient informations, right? And then if you see the operations performed, findings, right? So each category should go into the appropriate FHIR resource type. For example, complaints, right, can go into like either conditions, I guess, probably, right? And then medical history also should go into appropriate FHIR resource. And then you can also see like there are like a couple of lab tests which are made. So some observations have to be created. So you might have to extract all these informations, create the relevant FHIR resources for them, and then bundle them. And the final FHIR bundle is the output that has to be shared. Now, one more important thing is these PDFs can be like text formats which are selectable, right? Or it could be like image format also. So which are not like text. So this could be like images as well. So you might have to handle both the formats. Yeah, that's about the problem statement. Thanks, everyone.
Yeah, thank you, Chandrasekhar and Chinmaya from NRCS. Now I invite Mr. Arun Sharma, who heads Business Excellence at Aditya Birla, to walk us through problem statements 4 and 5. Post this, we can take up any and all questions you might have.
Thank you, Sadhna. Good afternoon, everyone. And as Sadhna said, my name is Arun Sharma, and I head Business Excellence and Customer Experience functions for Aditya Birla Health Insurance. So today I'm going to present two real world business problems that are the biggest problems in health insurance world and that we deal with daily. And your challenge is to use NHCX capabilities to solve these. So one is related to fraud detection, and the second is related to the claims processing, which is the biggest moment of truth for us. So first problem statement is fraud management and detection leveraging NHCX. So I'll give you some context first. So in our current environment, we do have triggers and we have rules also to detect suspicious claims. So how the reality is this? So these triggers produce too many alerts. And you know, if everything is a red flag, then nothing is a red flag practically. So this leads to a number of operational issues. Like our investigation teams get overwhelmed, so they need to work on a lot of cases. Then investigation cost also go up. Then claims takes longer to settle, and customers get frustrated. So when they are questioned or they ask documents repeatedly, because in some cases multiple queries also could be there. So and this leads to overall turnaround time becoming longer. So but even more importantly, the genuine and honest customers and the good hospitals end up getting caught in the same net as fraudulent ones. So and this is something that nobody wants. So we as insurers also don't want. Actually, customers also obviously hate it. So fraud, waste, and abuse, and we call it FWA here. So FWA increases the total cost of claims. And when claims become expensive, obviously premiums go up. And that means honest customers end up indirectly subsidizing fraudulent behavior, which obviously we don't want. So now this is where NHCX becomes a powerful enabler, and it can help us in multiple ways. I will describe 3 or 4 use cases here, but so there is no limit. Actually, it's up to your creativity. Either you can work on these business use cases, or you can create your own use cases, and that's why I have set up the context first. So first one is we have FWA models, fraud, waste, and abuse models based on our own data, and obviously we have one insurer's data, and so this data is limited. So NHCX has a lot of structured data for all the insurers, all the hospitals, etc. So you can create a much powerful and accurate FWA model. You can build a fraud prioritization engine that reduces false positives and pushes only high risk cases for investigation. So that leads to lower cost of investigation and obviously lower or maybe reduced inconvenience to the customers. Second is you have huge unstructured data also. So if same claim is getting submitted to multiple insurers, probably we can't catch it, but you can red flag that because you have data for all the insurers and hospitals. Third could be when we trigger a case for investigation. Investigators ask for documents from the customers, from the hospital. Sometimes they ask these documents in multiple instances, so multiple queries are there. So NHCX has integration with Abha already. So we can take some of the documents from there. So it will reduce investigation time drastically and obviously inconvenience to the customer and hospitals. Fourth could be you can also red flag repeat fraudsters. So you know the behavior of the customer, behavior of the hospital. So you have all the data to analyze. So you can red flag that these entities, customers or hospitals are the repeat fraudsters. So that's about the first problem statement of fraud, waste, and abuse. Now coming to the second one. So we need to go to the next page. Yes, this one. So second one is on optimization of claims processing in terms of time and cost using NHCX. So today you might be aware that regulatory expectations are there and they are very clear that all the insurers must process cashless pre-authorization claims within 1 hour and discharge approvals within 3 hours. And these timelines earlier used to be from last document received, but now IRDA's guidelines are that these timelines should be from first document received. And I'll explain what is first document received. So let's say we get the intimation of claim. That's where our meter or timeline starts. Earlier, what we used to do, we used to ask for missing document. We used to query. And then let's say I'm waiting for 2 more hours for getting that document back. So every time I reset my timeline or the watch or the meter. Now, irrespective of query or number of queries, whether document is missing from hospital or customer, it doesn't matter. From the first intimation, my time starts. So that's the much bigger challenge for insurers. So plus, our aspiration is also to go beyond compliance, because 1R and 3R are the guidelines, but we want to process as soon as possible. If not straight through processing, we call it STP. At least within few minutes, we should be able to adjudicate the claims. So there could be many business cases or use cases here also. So I'll explain maybe 3 or 4, and it's now up to your imagination or creativity. You can create your own use cases also. So first one is, we get the claim intimation via hospital portals. So what hospitals do, hospitals scan the minimum required documents along with proposal form, etc., and send us those claims via the portal. In some cases, roughly 25-30% cases, they also send those via emails. So then we have queries. So we ask for more documents, and that obviously takes time, which is crucial for the customer who is waiting to get discharged at the hospital. So NHCX has integration with ABHA, so it can help us in providing the required documents quickly. Second, and probably the biggest pain point here is, so we adjudicate the claims based on certain guidelines, ICMR guidelines, or maybe WHO guidelines. But these are just the guidelines, and not all the hospitals or doctors agree with them, and they are not even compelled to agree with those guidelines, because these are just guidelines, not the mandates. So based on the huge data for various hospitals and claims, if NHCX could come up with the standard treatment guidelines, and that most of the hospitals agree, could lead to huge effort and huge cost reduction and huge friction points for the insurers as well as the customers. For example, so 2-3 things are possible. A procedure diagnosis consistency checker that validates whether the treatment makes sense for this sickness or this ICD or not medically. Second could be length of stay appropriateness engine that flags overstays. So let's say for malaria, average stay length of hospital stay 3 days. Why are you charging for 5 days? For dengue, it should be 4 days. Why are you charging for 6 days? So certain guidelines that all the hospitals agree with. So that could be probably the biggest one. Third could be on overbilling. So we need to check for overbilling from hospitals. So we compare bills with our agreed tariffs. So we have the agreements with the hospitals on tariffs, but we do not have this tariff agreement with all the hospitals. So we can't compare bills of a large number of claims with standard tariff. So here also NHCX can play a big role. So they can highlight the overbilling for the procedures based on their huge data set for various hospitals, because they will know what is the agreement with that hospital, with other insurers. So they have data for everyone. So they can also estimate the billed amount based on the hospital type, city the hospital is situated in, and the ICD or sickness. So they can provide the estimate, and they can figure out whether the actual bill is much beyond the estimated one or not. So they can highlight that. Fourth could be NHCX can help in deeper penetration in automated claim intimation for cashless. So as I said earlier, we use hospital portals to receive cashless. So 70-75% cashless claims we receive via that portal, hospital portal. But remaining 25% claims we receive via emails. And then we need to use either some kind of automation using maybe RPA bot, or using, let's say, Power App, Power Automate kind of tools, so that I can automate the registration of that claim for which I have received the documents on email. Right. So you can help us in improving compliance to send the claims via the portal rather than manually, because NHCX will be a common platform even in rural areas for the smaller hospitals also, where probably our provider network is not, our provider portal is not there. So NHCX could be the answer. So these are I explained 4 use cases for fraud, waste and abuse, and 4 for claims processing. But as I said earlier also, don't limit your imagination to these 8 only. So you can create on your own use cases also. So I would say please focus on showing how NHCX can transform the way we detect fraud and process claims. And I would say all the best. I'm excited to see what each of you will build. Thank you.
Thank you so much, sir. I will quickly cover the hackathon guidelines and then we can take up questions. So, for everyone who's joined, the first thing that I would like to mention is the submission package. So for the first three problem statements, that is the FHIR utilities, all participants are required to prepare a complete submission package. Anything that's incomplete will not be evaluated. So this should contain a detailed README with the solution architecture, setup, instructions, dependencies. It's all mentioned in detail in the submission guidelines. So I won't go into too much detail on the specifics of each of these elements, but we will require a detailed README, an end-to-end video demonstration, the complete source code in the zip format, an output folder um, containing the FHIR bundle along with the FHIR mapping Excel. We've provided the input data for which you will have to provide these two items as well. The solution, of course, must be fully functional out of the box, and there should be zero critical errors and fewer than 5 non-blocking warnings. So we expect you to have done these checks yourself as well. And we also have a code freeze protocol, that is, prior to submission, all participants must ensure that their code is finalized with a proper timestamp. This will ensure that we are also evaluating the correct version and can easily be referenced during subsequent review phases as well. And the upload requirements, the complete submission package that I mentioned, that is the video demonstration plus the README, the code base access, the FHIR output, and the FHIR mapping must be uploaded to the drive folder. I'm sorry, I think there's an error on this slide. I will open the submission guideline instead. So I think it'll be clearer for all of us to go through that. Give me 1 second. Yeah. Yeah, like I mentioned, the submission package should contain all of these items for the first three problem statements. For problem statement 4 and 5, because they're business use cases, we require a consolidated deck with all of these sections, a summary, the business problem that's clearly defined, the approach and how you're going to be using NHCX or ABDM, the business impact and value realization. It has to be concrete in how your approach will translate into measurable business outcomes and also strengthening levers. NHCX is not a static sort of entity, right? So in terms of what can be done better or what can be focused on in future in terms of your recommendations or suggestions, that would also be welcome for problem statements 4 and 5. In terms of how exactly you should submit, we have the process steps detailed here. First, you'll receive an email with the participant ID and a Google Form link. Then your required files should be uploaded to your own Google Drive with a main folder and the relevant problem statement folder. Then you should upload each of your required files inside each of those folders and provide edit access to official email IDs that we will provide. We've gone and explained all of this in detail in the rest of this document, but I think the submission broadly is that you will have to provide us a Google Drive link with your comprehensive submission package. And in terms of the evaluation, I'll quickly scroll to that section just to give you an idea of what to expect. There will be a stage 1 of initial screening where your submission package will be evaluated. And based on this, qualifying participants will be shortlisted and required to do a live demo virtually in front of a jury, tentatively on March 3rd. But yeah, I'll stop here. I don't want to overwhelm you with too much details on these guidelines, but feel free to check all the information out on the website. Now I'm going to just allow everyone to unmute themselves so you can come in with any questions to any of us. Yeah, to everyone who's joined, do you have any questions? Yes, Dr. Abdul Sheikh. Dr. Abdul, can you hear me? I've allowed you to unmute yourself so you can just speak. Okay. Virat, can you hear me?
Yes, I can hear you, Sadhna. Hi, good afternoon.
Yeah. Hi, Virat. You can maybe go ask us your question.
Okay, so quick question. I had signed up for the hackathon slash the event, but haven't received the confirmation. So anything on that? Or...
Yes, you will receive a confirmation by, I think, 22nd or 23rd.
Okay, got it.
With all the details as well. So yeah, don't worry about it.
Sure, okay.
Question. I know it's got answered in the chat, but I want to be sure before we can conclude. When you say open source, the solution built should use open source, or the outcome of the hackathon submission, the software will become open source?
Yeah, that's an interesting question that we are also sort of internally discussing at the moment. So I will have to get back to you on the clear details on it. But ideally, the idea is that the service that you've built should be built using open source tools, right? Because if your service is going to become, it's a complicated question. If you're using proprietary softwares or tools that you own an IP to previously, how exactly would that become open source? So that's something that we're internally pondering. But I think you should keep in mind that the service is definitely intended to be for the industry. I'll get back to you on that. We are discussing this. But I think what I can answer for now is that it has to be an open source microservice because we intend for it to be a solution that anyone in the industry will be able to use.
For now, we'll consider as open source, but if you could come back, that will really
Yes,
help us
of
to
course,
decide
I'll
this.
do that. Yeah.
Thank you.
I also have, I see John, you've put a question on the chat. Do you want to come in?
Yeah, hi. Thank you so much for all the info that you provided. My quick question is the 4 and 5, right? That sounds more like a business use case. So I'm just